Hey everyone, Professor Wield here. I'd like to share with you some thoughts on how to do the homework project on writing G code. There's a couple of documents that will help you along your way. One of them is this slide presentation, which gives you an overview of the homework assignment. The other is a little more detailed look at how to do it in this Word document. So our assignment is basically to write G code that matches this drawing for toolpaths, creating an SDSU engraved nameplate, and then to replace the SDSU with your own creative design. I like to structure these assignments a little bit more like what you might see in an industry environment. So imagine that your boss has come up with a couple of pieces of software, online software, and said, can you take a look at these and see how they work and if they would be useful for us? And so you've decided that you're going to write some G code to test that software. One of them is the SDSU nameplate, the other the creative design. So as you're writing up your presentation, which will be in a slide format, imagine that you're doing this as a report back to your boss, which would include executive summary, some key bullet points, screenshots, etc., as well as putting the actual code that you wrote in a text readable format in your appendix so that I could copy it and paste it and try it out if I wanted to. In addition to these two documents, which you'll find in Canvas, I would also refer you to this slide, slide 56, in the slide deck from the lecture, slide deck 1.2. And I'll show you in a minute how we can use that. So the first thing we need to do is pull up that quick and dirty simulator. The quick and dirty simulator link is in the assignment. When you click on that link, it will give you some sample code already with the simulation of it. First thing we're going to do is to delete that, and we got to replace it with our own code. So where do we start? What I would suggest, we look at slide number 56 and copy, well, let's say leverage, the code that's in the first few lines here. So I'm just going to copy that and paste it right here. I can go into that code. We know that whatever's in parentheses is a comment, so I'm going to change this to SDSU demo. Oops. I'm going to change these initials to my initials. I'll change the date to the current date. I'm recording this video February 3rd. I'm going to leave this CNC as Tormac. The controller we're going to use online is for a Tormac milling machine. Our workpiece, it's 3 inches, maybe it's 3.8 inches. By 2 inches by a ½ inch thick. It's PVC block. You could also imagine it to be aluminum. We're going to use tool number 1 is this says 1/8 inch. I'm going to change it to ½ inch. ½ inch end mill. I'm going to add a tool, which is T2. Part of the requirements of this assignment is that you use 2 tools, demonstrate the use of 2 tools in your both in the SDSU and in your creative design. 1/8 inch end mill. We've got some starting blocks here. This is it cancels the prior settings. It sets absolute value. Sets the fact we're working in English instead of metric. The next line says select tool number 1. And G43 says compensate for the height of tool number 1 by going to a box somewhere which will give you the exact offset for that tool. Turn on the spindle at 1500 RPM and go as fast as you can to some coordinates. I'm probably not going to use those coordinates. So let's start there where we can make a change. One of the things I want to do is pull up that drawing. So the first thing we want to do is go as fast as we can. I'm just going to choose to go to the origin. That origin I'm going to also choose is in the back left corner of the part, and that origin sits right on the surface of that part. So I'm going to go X0, Y0, and instead of going to Z0, because that's right on top of the part, I'm going to let it stop, let's say 1/10 of an inch above the part. So it's going to go as fast as it can from its home position down to 1/10 of an inch above. From there, I'm going to create the border. So I'm going to just type in what I'm doing in this next block in comments. That's the border. I'm going to tell it to go down. We're 1/10 of an inch above the part. I'm going to say go down at a controlled feed rate, Z minus 0.1. We have the 1/2 inch cutter. Tool number 1 is 1/2 inch. It can easily go 1/10 of an inch. It can go up to half its diameter deep. So we're going to go 1/10 of an inch down, and we're going to go at a controlled feed rate. So that feed rate, I think I think it said what, 12 to 15. I'm just going to live on the wild side and go at about 50. You can make it whatever you're comfortable with. We're not actually going to be machining with this. Just be looking at simulations. So I've done a controlled feed rate. I've gone down. Now I'm going to I'm in the part and I need to go to a value from the origin over to here. I'm going to say that that's X3.8. The Y value stays the same. I'm still at Y0, so I'm just going to leave it there. I don't need to repeat coordinates. Anytime I give it something, it will keep whatever it has and just change the item that I've changed. So I'm at X3.8. Now I want to get down here. That's going to be G01, a controlled move down to X stays the same, but Y changes. Y changes to -2. So if my origin's here, plus Y is going up, minus Y is going down, minus X to the left. So I'm operating out here in the plus X minus Y quadrant, commonly known as quadrant 4. I don't have to give it I don't have to repeat the feed rate either. It will take the last controlled feed rate and say, if you're doing a G01 and you haven't told me anything different, I'm just going to use that feed rate of 50. Makes it easier too, so that if you do want to change it, you only have to change it in one place. So I'm down here at -2. I'm going to go to G01. And I'm going to go over to X0, puts me right over in this area. G01 back to Y0. And I'm going to want to lift up the tool because I'm kind of done with the border. I'm just going to lift it up a little bit. G01 X 0.1. So let's just run it. I don't want to put in everything. I just want to debug it a little bit at a time. So I'd put the border in. I would hope to see the border. There's the border. I'll just pull it over here. You can see the border. It comes in two views. The top view, which I can, sort of an isometric, I can see the depth. And, oops, there's the zoom. And we can see the bottom view, or actually the top view, which is just a rectangle. So we see it go down, it goes around, comes back up. It's exactly the way I would have imagined it to be. So let's do our S. To do the S, I'm going to comment what I'm doing here. So it's S letter. You can call this anything you want. I'm not putting a comment next to each line. I could, but that gets a little tedious and it's not that necessary. So if I'm doing the S, what I want to do is go as fast as I possibly can from where that cutter is. I'm going to choose to do this part of the S. There's no right answer here. Anything will work. G0, you could start on the U, you could start at the bottom of the S, anywhere you want. I choose to start here. G00, go as fast as you possibly can to X 0.9. Go to Y. At the same time, we're going to go down to Y minus, because we're in the minus side of the coordinate system, minus 0.5. My Z is not going to change. I then want to go down into the part. I've got to go down Z minus. How far do I want to go? I want to go to a depth of 0.1, but I got to do it in two passes. So in the first pass, I'll just do minus 0.050, 50 thousandths of an inch down. Once I'm down, I can start cutting. This first cut from here over to here is going to be, looks like a counterclockwise move. Counterclockwise, G03. The end point of that move is right here. So that's at X4. The Y value hasn't changed, minus 0.5. Now it hasn't changed. So I didn't have to write that minus 0.5, but I find it easier when I'm trying to debug arcs to make sure that that end coordinate is what I would expect it to be. So here I do add that redundancy. Now this two endpoints, the starting point and the end point, don't define an arc fully. We've got to figure out what that radius is or what the center of the arc is. In this case, it's easier to put in the radius, because this call out here, 4x r 0.34, says that there's 4 arcs that are all the same, and I can see what they are. They're the top and bottom of the S's. So I'm going to put r 0.34. So I'm using all capital letters. That program actually, typical G code, will not care, but you'll see it written in capital letters as the convention. So I've made an arc over here. Now I just got to work my way through these zigzags all the way down to that other arc. I'm going to do that real quick. Those are G01 straight line moves. That's Y minus 1. Next move is G01 X 0.9. G01 to Y. These are absolute numbers, so absolutely I'm going down minus 1.5. And now I'm down to this corner and I need to do that arc. That's to get from here to here, I'm doing a clockwise arc. That's going to be a G02. And my endpoint is at X 0.4, and I'll put in that redundant Y value of minus 1.5. Arc radius, same as we said before, R 0.34. And that was actually the first pass. So I think what I'm going to do is just identify this as first pass. Let's just see if it works before we move on. So I'm going to hit the simulate button. And my simulation doesn't look like I would have expected it to. It's going from this point to that point and back again. So something in here isn't quite right. I'm going to need to look at my program and debug it. That's the absolute value at depth of 50 thousandths. Then I'm making a counterclockwise arc, but I typed in a 4. Maybe you've noticed that before I did, and you were saying, Professor Wheel, you got an error here, you got to fix it. We'll fix it now. And that's why we run these simulations often. So I've got my S. It looks the way I think it should look. I'm ready to go on. I want to do a second pass. How am I going to do that? I'm just going to take that set of code, put it down here, paste it. I'm going to call that a second pass. Second pass, pretty much the same thing. I got to figure out the interface between these two, but the big difference is I'm going down to an absolute value depth of 0.1. So I'll make that change. Now I got to figure out how do I get from one to the other. I'm at the bottom of the S here. I'm at this point of the S and I need to go back up to here to be able to do it. So I got to raise up by G01. We could do a G00. I'm just going to do a G01 so I don't get the machine too excited. To height of 0.1, I know I can clear. And from there, once I lift up, I know I can get over to this area. So now, theoretically, this should, and I know I got to lift up here at the bottom of my second pass. Oops, G01, Z 0.1. Got to lift up here to go back. Let's just simulate that and see what it looks like. Looks pretty good. So we got 2 passes. But wait, we did all those 2 passes without doing a tool change. So remember the requirements of this lab are to do a tool change to run that border with a 1/2 inch, but run these kerf cuts using 1/8 of an inch. So how am I going to do a tool change? I can leverage my code here. Copy, paste, do a tool change right here, but we're going to tool 2. And tool 2 is going to have a different height compensation, G43 of H2. Let's use the same spindle speed, just out of convenience, S1500, maybe a smaller end mill. I'd use a higher speed. You can calculate that using your speeds and feeds. We're just going to put that in right now. So now I've made a tool change. And any further letters that I make, for example, if I want to do a letter D, I'm not going to do it here. I got to leave something for you to do, but I'll leave space for it. And then you'll put in your geometry for the D. Eventually you're going to get done, and we're going to put in some code at the end. So what code should we put at the end? What I'm going to do is leverage again that one slide that I had, that very cool slide that I had in the lecture. It's got some ending code right here, which is copy, paste. I don't like all this space in here. Not sure where it came from. Probably. So I'm just going to clean that up a little bit. I'm using the delete key on my keyboard. Standard copy paste commands, as you saw. So what we've got here, at the end it says, well, make sure you lift up at least 0.1. Stop the spindle. Remember, it's rotating. Go as fast as you can to some height Z3. And then end the program, reset it to the beginning. So those things are necessary, which would make it convenient. In order to do a tool change, especially if we have to do it manually, what I want to do is tell it to go as fast as we can. G00 up to a height of, let's say 3 inches. I'm going to put another one down here. So we've got our code, and your next question is, let's see, so I know how to write the D, the S, the other U. What do I do? And I can take snapshots of this. I could rewrite the interior parts, the kerf cuts with the letters using my own cool geometry. All seems pretty straightforward, but how do I export this file? I'm going to copy it. I'm going to pull up a Word document. You could pull up a notepad. You can pretty much pull up whatever you like that we can save as a .txt file. So I'm going to pull up a blank one here. I'll do a copy, paste, just like that, because this online software is not going to, you don't have an account. It's just going to, it'll go away as soon as you exit that program. So here's what we got. I'm going to save it. Save as, let's call it a SDSU demo. Got to save it somewhere. I'm going to go ahead and save it to my download file, because that's my temporary spot where I can remember where stuff is. Save as, not a Word document. Save it as a plain text.txt. Typically, your controllers are looking for a .nc file. Some of them will take a .txt. So this one will take a .txt. A .nc file is what would be generated by the toolpaths when you run SolidCam, Fusion, or Mastercam, anything like that. So here's PathPilot. I've got an account here. You can follow the instructions to get your own account. Use your SDSU email. This company will have your name and email. If you get any marketing stuff, just tell it to stop. It's a reputable company. They will. I don't get any any junk email from them. So I'll sign in under my login by have a default here. I'll hit submit. I get to this place. This is pretty cool, because what's down here is a whole bunch of files. And this is your virtual USB drive. The USB drive that I asked you to get so you can carry files down to the machine shop. So what we got to do is upload our new file. I'm going to hit upload right here. I'm going to go to my two files. I got to use the text file. Click that. That's what I want to upload. Let's see if that's what happened. There it is. I got confused looking at some of the other files. So we've got it on our USB drive. We've got to take that over to our virtual controller. The controller, there's some different versions of it. I just picked the older one. I'm not sure which one was used for the instructions that I wrote you. They're all pretty similar, and it'll be pretty intuitive if you're on a different one, so I wouldn't worry about it too much. I'm going to enter the Path Pilot controller. That means I'm going to walk over to the machine. Takes a few minutes. This machine is going to be operating for me for 3 hours. I'll agree to this. And what I mean by that is anything I do here is going to be saved for 3 hours. I don't recommend that you save stuff though, because we got a lot of students that are going to try to get on here and it'll bog it down. More on that later. We've made it into the machine. Now the first thing we got to do is take our go to the file menu so that we can find our USB drive. Here's our USB drive, virtual. We're going to look for that file we just made. This is it. I got to take it from the USB drive, put it onto the machine. I'm going to just copy it over. The machine's got a number of different files on it. You can see them. If we open these folders, there's some sample ones there, which might be pretty cool to look at. But we want to see ours. So I'm going to highlight that, and I'm going to say this is the G code I want to run. So I'm going to hit load G code. And it immediately kicks up on an error because we haven't set up the machine yet. So what we need to do is set up this machine. I'm going to go over to main first. It says, yeah, it looks like you picked up that S. Here's my code. This is starting to look familiar. It's got my initials. Go to view options. I like to pick ISO. And it's saying the tools are end mill, eighth inch, end mill, quarter inch. Wait a minute. That's not the tools that I want to use. So let's go over to tool offsets. We got to set up the right tools here. So I'm going to click on this first tool, and that first tool, as you remember, we decided that should be a 1/2 inch end mill. I'm going to make it a 1/2 inch. And I'll go to the end here. I'll hit enter. And it says Path Pilot wants to change tool diameter. You okay with that? Yeah. So we're looking, see it says 1/8 inch in that box under diameter. We want to, I kicked out another error because we're not done yet. It now says 1/2 inch, so that's good. We got to change tool number 2. Tool number 2 is 1/8 inch. And I'll just say that that's an 1/8 inch diameter. I expect it'll do the same thing and change this number to an 1/8 inch. If it doesn't, I could always change it myself. Kicks out another error. These errors have to do with the z-axis because we haven't zeroed and homed the machine. So I'm going to go back here. It looks okay. Now you notice the lengths. These are like the H1, H2. It's saying go to H1 and figure out how big this tool is. We'll do that in the machine shop to fill out those lengths automatically, or tool offsets. Some offset might be 0. The next one might be the difference between the length of that tool and the next tool. So let's take a look at this from the main menu. We've got the view, we've got the code. We're starting at the top, and we'll hit cycle start. We've already loaded tool number 1, and it's going through. That 1/2-inch cutter, if it's on that center line for the tool path, it will be cutting a 1/4 inch in on the material. The next thing it asks us is to insert tool 2. Since this is set up to be a manual change, we'll say that we've raised up that tool and exchanged it for 1/8 of an inch, and then hit the cycle start. Looks like 1/8 of an inch tool. We're expecting it to go around that S in 2 passes. There's the first pass. Whoa, it's coming way up 3 inches. That looks a little bit inefficient. You remember I sort of deliberately put that in to show you something. And the thing I want to show you, because now we're at the end of the program, is how do we modify this code while it's in the machine. What we'll do is come over here to File. We'll go Edit G-code. I now have access to the G-code itself, and I would say, you know what, my comments tell me where I'm at. So between doing the first pass and the second pass, I really don't want to go that high. It's just a waste of time to go way up in the air and come back down. Important when I'm doing a tool change, but certainly not something I want to do just to get from one side of the part to the other. So I'm going to say save. Then I'll X out of this window. It asked me, do you want to reload what you did? Yeah, let's reload it into the machine. So it's reloaded. Let's check that. You remember down here at the end of the first pass, we eliminated that G00Z3. We've already homed the machine. We're ready to run it again. We're already at the top, so I don't need to hit reset. I'm just going to go ahead and hit cycle start. First thing it does, get to that, hey, put in the tool 1. Tool 1 should be a 1/2 inch end mill. You got it there? I think so. Yeah, and there it is. That 1/2 inch tool simulated by that larger diameter cylinder. It's going around the geometry, cutting along the tool path that we prescribed, and of course cutting on the inside. It's actually cutting in a climb cutting mode when it goes clockwise. It says to insert tool 2. We'll do that, at least virtually. There comes our 1/8 inch cutter. By the way, I could speed this up if I wanted to. I'm going to speed it up double the speed. Now remember, I used a feed rate of 50, so now we're running at 200. And that makes the simulation go a little bit faster. So there we are. So what we've done is demonstrated how to write the G code for the S. You can do the others. How to transport it into PathPilot, and how to do a little bit of debugging. One thing I want to mention, if you do debug this code and you say, actually, I'd really like to save it. You've changed the code on the machine. If you want to put it back on your virtual USB drive, copy it over, overwrite it, and now you can access it right here. The updated code will be right here, and I believe that's an updated time. Other word of caution, when you're in this window, don't keep hitting enter PathPilot. You're just going to keep generating windows like this, and you'll have to create new machines. Every time you create a new machine, it taxes the software in a computer on the other end, makes it difficult for other students. So once you launch it, just realize you can go back and forth between these two tabs. And when you're done, what I'd like you to do is delete your machine so it doesn't have to retain it, because it's going to save it for about 3 hours. So I hope that video is helpful and instructional. Hope you went through the parts that you needed to, sped up the parts that you already knew, and looking forward to seeing what's your evaluation of these two pieces of software. One simulation helps you write the code. The other simulation will help you understand how it will run on this milling machine. Two different purposes. Did you have any issues? So write that up in a presentation style format. Look forward to seeing your work.